and we're moving on to the next speaker. And this again is a virtual, so we have two more virtual talks now. So first, Veronica, if you share your screen, the floor is yours.
Yeah, I think, Ola, can you unshare your screen? Great. Okay. Hello, today I'll be presenting on our work, Two's Company, but Six is a Crowd, Emergence of Conventions and Multi-Party Communication Games. This is joint work between me and Robert, Noah, and Mike. I want to start off with a perhaps obvious observation that much of our communication in everyday life takes place in groups. For instance, in classrooms, teachers will communicate with an entire group of students up front in a lecture, but students will also work together in groups that involve group conversations. Similar dynamics take place in the workforce. For instance, someone may give a presentation to a number of their colleagues, or a group of colleagues may get together to discuss a problem. These multi-party communication events also take place socially. For instance, a group of friends may get together for a conversation, or people may talk to multiple family members at once over dinner. Intuitively, these group conversations have a couple dynamics that are not present in one-on-one conversations. The speaker may be talking to listeners who have different background knowledge, and therefore they must need to balance between talking to speakers who already know what's going on and talking to speakers who need to be filled in more. Additionally, listeners can talk to each other when there's multiple listeners, which can lead to either helpful dynamics if a listener is able to add clarification, or less helpful dynamics if listeners engage in crosstalk and go off on a tangent. Despite these differences between one-on-one and group communication and the ubiquity of group communication in real life, most of the research on, in psycholinguistics at least, on communication has focused on dyadic contexts. So much of this prior work on referential communication tasks has been dyadic. And this is the type of research that I'm talking about. These are studies where people get usually brought into a laboratory. One of them is assigned the speaker role. They get to see a picture, and then they will describe this picture to the listener so they can match. So the speaker might say something like, it looks like a person sitting down. They're kind of hunched over and sad looking. And then the listener, based on this, might ask for some clarifications, like facing left, I think I see it, and they would select the target. I should note there has been a little bit of research using this sort of paradigm that has included groups of 3 to 5 people. However, it is focused primarily on contexts where a speaker and listener develop a rapport and develop some conventions about how to refer to the figures, and then additional listeners who aren't part of that convention are added to the group. So it's very explicitly exploring how a speaker talks to listeners with sort of artificially different backgrounds around the task. In contrast and complement to that work, in our current work today, we'll be examining how this adaptive communication unfolds in multi-party tasks when a group of people do this as a group from the beginning. The key phenomenon of interest in this literature and in our work today is this idea of reduction over repeated reference. This is the process by which people develop a sort of nickname for an image over repeated references to the same image with the same partner. This is very robustly found in the dyadic literature. As an example, with this as the target image, one pair, the first time they described this image, the speaker said, I picture someone wrapped in a blanket. You cannot make out their legs or arms. Their upper body is up straight, and it looks like their knees are pointed slightly to the right. The 6th time this pair referred to this image, they just called it bundle. So you can see they've developed some conventionalized concept for how to think of this image as being like swaddled or wrapped up in a blanket as a bundle. There's some kind of carry through of this idea that crystallizes out into their last description bundle. However, this is specific to this group. Other pairs of people also come up with nicknames, but they end up on different nicknames. For instance, a different pair doing the same task, their first round was, it is the one that doesn't really have anything poking out, except at the bottom right is a little triangle shaped almost like a boot. And in their 6th round, they call this boot 1. I believe to contrast with a different image that also looks like a boot. So we can see here that within a pair, people are really good at forming some sort of conceptualization, agreeing to it with their partner, and then once they both seem to understand it, it sort of develops into a nickname, but that these nicknames differ between pairs. In the current work, we're extending that to look at whether the same kind of nickname convention formation happens in groups. To do this, we recruited 390 prolific workers to play a communication game in groups of 2 to 6 people. We had about 15 games in each of the size conditions. During this game, they would go through 6 blocks of the 12 targets each block for a total of 72 referential trials, and then we rotated the speaker between blocks. So here's a little video showing what the interface looked like for participants. This is the speaker view. So they see all the 12 images, and one of them is highlighted for them, and then they'll describe that to the, in this case, 2 listeners using the chat box. Everyone can use the chat box, so listeners and speakers, the speaker, everyone sees everyone's messages, so there can be back and forth clarification. And then once the listeners click on the target image, everyone will get feedback. So the speaker sees who clicked what, and then which were right or wrong. The listener's perspective is similar. They see the 12 images in a mixed up order, and they're trying to click on the target that's being described to them. And once all the listeners select, there will be feedback. But for listeners, if they get it wrong, they only see that they get it wrong. They don't see the correct answer, and they don't see what other listeners chose. One more example in the listener, they make a choice, and then we'll get feedback. So if they're correct, they see that they're correct, but they don't see what other people chose. So that was 3 trials. There'll be trials going through all 12 images with the same speaker, and then it'll rotate and someone else will be the speaker and they will describe all 12 images over again, but in a different order. And then we do this for a total of 6 times through, which means that everyone gets to be the speaker at least once. So this experimental setup lets us address questions about how group size affects convention formation. We've got a few questions that I'll walk through. The first of them that we'll look at is whether accuracy increases. So one of the findings in the dyadic literature is that people are good at doing this kind of iterated reference task. They start out pretty accurate and get increasingly accurate. So we're interested in whether that shows up in these multi-party games. On the graph, on the x-axis is the block. So we had 6 repetitions through all the images. Those are the 6 blocks. We're color coding how big the games were. So the 2-player games are in yellow, and then the larger games are progressively in darker colors. These same colors will be used throughout future graphs as well. For this graph in particular, on the y-axis is a listener's selection accuracy. So how often the listener was able to correctly select the target. We see that people start off fairly accurate, maybe 80 to 85% correct on the first block, and then this increases over the course of the game to close to a ceiling of like 95% accuracy at the end. So our 2-player condition, you can think of as replicating prior work in this high and increasing accuracy, but now we're extending this and finding the same pattern of accuracy also holds for larger games. So what we found here is that accuracy increases, meaning that even in these groups of up to 6 players, people are able to do the task, like get a reference expression that works for their listeners, and then have it go better over the course of the game as well. The next thing I'll talk about is how group size affects the reduction process. So I talked at the beginning about the sort of nickname formation where people reduce to a nickname. A kind of quantitative way of looking at that is that speakers say more at the beginning and less at the end as they kind of go from long descriptions to short nicknames. So that's what we're looking at here. On the x-axis is block, again, the 6 repetitions. On the y-axis is the total number of words the speaker said that block, so summed over the 12 different images they described. Here I'm only showing the data from the 2-player games. The black line is the overall smooth of the group average, and then the individual yellow lines are the data from individual games. What we see here is that the speaker says a lot of words at the beginning in block 1, and then this declines over the course of the game, so it looks like almost an asymptote in rounds in blocks 4, 5, and 6. This same pattern holds for a lot of the individual games. Most of the yellow lines go down. The pattern also holds for our larger games with 3 to 6 players. So across each of these, if you look at the black lines, they all go down, showing quantitatively that we're seeing reduction. You might notice that the colored lines for these larger games are a little more erratic. So we do have some games where one of the speakers who rotates in the middle says more than a previous speaker. Right, these are different speakers. We have some variation there. but the overall trend is still towards reduction. The other thing to look at here that's a little bit hard to see, but that comes out statistically, is that in larger games, speakers say slightly more words than they do in smaller games. This is an overall effect and doesn't interact with the block reduction effect. It's just that in larger games, speakers say a little bit more. So what we saw there is that group size doesn't directly affect reduction. However, bigger groups do seem to say a little bit more, but across the group sizes, we do see this reduction phenomenon where they say more in early rounds and less in later rounds. The last thing and sort of the key thing we want to look at is how do conventions emerge in these larger groups? So in order to do that, we need to somehow dig into the sort of rich language transcripts we have, but we want to do so in some sort of quantitative way. So what we do is we take the utterances and we vectorize them using Esperit sentence embeddings to turn each sentence, each utterance that a speaker said into some point in this high dimensional space. And then by comparing the points corresponding to different sentences, we can compare the sentences. So if two sentences have similar meaning, we expect that their embedding points will be close together in meaning space. That's what the embedding is supposed to do. And then the angle between those 2 points will be relatively small, which means that there'll be a big cosine between them. And so it'll have a high cosine similarity. In contrast, if there's 2 random sentences that aren't related at all, we expect them to map into kind of random parts of this vector space, have a big angle between them, and thus have a small cosine similarity. And that's pretty abstract and mathy. Here's sort of a concrete illustration. So these are different ways one group described this figure over different blocks. And we can look at the cosine similarity between pairs of these descriptions. So on the top row in round 4, this group described this figure as penguin stomping feet, dinosaur, square head on the right. And in block 6, they called it stomping penguin dinosaur. And these 2 utterances have a cosine similarity of 0.83, which is quite high, and kind of intuitively makes sense. These are like similar conceptualizations. Continuing down the chart, again, comparing to the penguin stomping feet, dinosaur, square head on the right. In round 5, they said dinosaur head tilted backward right. These 2 have a cosine similarity of 0.62, still fairly similar. Going less similar, again, comparing to penguin stomping feet, dinosaur, square head on the right. We have head tilted backward, one leg raised, little standing position. And these 2 compared together have a similarity of 0.37. Lastly, a dissimilar pair. In round 2, they said head tilted backward, one leg raised, little standing position. And that compared to the round 6, stomping penguin dinosaur, has a similarity of only 0.14. So those are fairly dissimilar. I hope this illustrates that what we're getting at with the cosine similarity metric seems to reflect some aspects of like actual semantic similarity. So we're going to use this metric for a couple of different analyses. The first of those is looking at how descriptions diverge across groups. So this is looking at how 2 different groups describe the same figure and whether those descriptions are similar or different. Again, on the x-axis is block for our 1 through 6 blocks, and we're color coding by player count. On the y-axis is this cosine similarity metric. So higher numbers mean that the 2 sentences are more similar to each other. What we see here is that similarity declines across block. So people describe figures in more similar ways across groups in early blocks, and then they diverge into different descriptions in later blocks. Here's just an example of what that looks like. So these are how some different speakers in 6-player games describe the figure shown in block 5. One group called it slide tackle footballer. Another called it abstract one. Another called it the same zombie one arm up, one down. And another called it the messy one, square and triangle on top. So these all feel like very different conceptualizations of this figure that these different groups used. So all of them have diverged from whatever vague descriptions they gave at the beginning to these different places. The complement to the descriptions diverge across groups is that they converge within groups. So here we take as the convention whatever the speaker said in round 6 in our last round. And then we compare what they said in the earlier blocks, block 1 through 5, to this final description that we take as the convention. So we're looking at the distance or the like the similarity between utterances in round 1 and round 6, and then block 2 and block 6, and so forth. On the x-axis is the blocks 1 through 5 that we're all comparing to block 6. And the y-axis, again, is cosine similarity. So higher numbers are more similar. What we see is that similarity to the description in the final block increases over the course of the game. And that this seems to do so differentially based on group size, with smaller groups showing similarity increasing faster and higher than larger groups. As a concrete example of what this convergence might look like, in one of our 4-player groups for the figure shown, their 6th round description was Pope. So that's what we'd be taking as the convention. And their earlier descriptions, in round 3, the speaker said, "It's the Pope guy," and then went on to describe it in detail for 2 sentences. In round 4, it was described as beggar or Pope. In round 5, it was described as Pope. So you can see how these descriptions sort of narrow in on the final description of Pope. That's the idea of convergence within groups that we're interested in. And so we see here that this pattern seems to come through regardless of group size, but we do see it happening even more strongly in smaller groups. In summarize, these experiments on groups of 2 to 6 people playing a communication game allowed us to look at how group size affected convention formation. We saw that accuracy increased, so people were able to play the game. We saw that groups, regardless of size, showed the reduction phenomenon, but the bigger groups say a little bit more overall. And we saw that conventions emerged in larger groups, much in the same way they emerged in smaller groups, except that convergence is slightly slower in larger groups. Going back out to kind of the big picture, much of the existing literature has been on communication games in dyadic contexts. In fact, it's actually been mostly on dyadic contexts of people with aligned incentives, so they win or lose together, and with similar knowledge state, even though this sort of situation is not reflective of many real-life conversations. In the present study, we tried to expand the sort of toy research world out a little bit by looking at games with more people to start to reflect one aspect of variation in real-life conversation. There are also other aspects that can be explored. For instance, in much real-life conversation, people have different incentives. So they may need to agree on reference, like what words are referring to what things, but they may be negotiating, and so their goals in the conversation are not aligned. Additionally, many conversations we have may be with people with different knowledge states. For instance, a domain expert talking to someone who isn't a domain expert, and vice versa, or like a parent talking to a child. So we've looked at one of these sort of many pieces of the actual richness of conversation today by trying to expand the sort of model paradigm up to more people. And I think this is part of a larger research program of taking our sort of toy model of reference games. It's supposed to reflect something about communication and adding on different aspects that reflect different parts of real life communication to that paradigm to learn where it shows variation versus not. With that, I'll stop. I'm happy to take questions now, but you can also contact me later if you want.
Thanks a lot. I see that we have 2 questions here in the room and maybe some online, but you can start.
Hi, thanks for the interesting talk. I noticed that 5-person groups had the lowest accuracy and seem to converge the slowest, like even worse than 6-person groups. Is that meaningful? Like, do you think there's something special about 5-person groups?
I don't think it's meaningful. So we're not super high powered on this because we've only got about 15 games per condition. So my guess, unless we run a lot more of that, is that with like our 5-player groups happen to have more people who are paying slightly less attention or whatever. That's just group variation.
Cool. Thanks.
So this is in some ways a follow-up to the last question, wanting a little bit of a deeper dive about the accuracy performance measures of the groups. In particular, I'm wondering in the bigger groups, was there evidence that particularly apt descriptions end up capturing more of what the group ends up saying? So like it seems like some of the descriptions are really good, like the penguin really was a stomping, and that's a great description. And so is there a sense in which those so empirically better descriptions sort of distribute more widely as a function of the big groups versus the small groups?
Interesting question. So I think what you're asking is like in larger groups, if someone gives a really good description, does that like catch on and more people use that description? Is that sort of the question?
Yeah.
Yeah. I think that's hard to tell. So we like have all the transcripts and could try to look at that. I think I need some like independent way of trying to figure out which are good descriptions so we could look at accuracy, but if people get things right.
I was thinking of using the accuracy when a particular description was being used. How often do people correctly get the right icon?
So like, yeah, I would definitely expect us to see that descriptions that people get correct tend to carry forward, in part because then the new speakers are aware of the connection. Yeah. But yeah, we could explore trying to look at that in more detail, or find other ways of measuring, like what are good descriptions if they're like surprisingly short early on, but still of high accuracy or whatever. Yeah, thanks.
Yeah, thank you. Hi, I was curious, since probably you have read many of these descriptions, I was curious about what you saw there, because I have read experiments with neural networks communicating about some like images, and we know that when you enlarge the population, the language tends to be more general, so that if you add another agent there, they can like adapt better to this protocol that the other agents have like learned. So that it means that adding people makes the language more general. And since the first examples that you showed us with only 2 speakers was clear, we saw that the words that they were using were clearly something that they understood because they had played the game, but we as a public could not really understand. So when you add more and more agents, they in the end converge on some descriptions that you feel like they are better, in the sense that if you add another person there, they would understand what they're saying. So something like that. So if you think that it's more general.
Yeah, I think we're not yet to a size of group where we can tell. So even in the 6-player games, some games converge on some really idiosyncratic descriptions, having read the transcripts. So they're still doing like approximately in jokes on some of them, that I don't think people outside would understand, like which one SAC person is or whatever. But you know, that's 6 people. We haven't run the game with 12 or 20 people. We might try to do that, and that's where we might start hitting like the need to use descriptions that are sort of universal even to naive listeners. I'm definitely really interested in that. Yeah.
All right, great, thanks. It's time to move on to the next speaker.